At the side of the course, flexible safety nets are used. Another skier of mass 76, ooh, we changed the mass, right? Falls normally. Normally, by the way, means at a right angle, perpendicularly, into the safety net with a speed of 9.6 meters per second. Calculate the impulse required from the net to stop the skier and state an appropriate unit for your answer. Well, remember that impulse is change in momentum, right? Okay, impulse is force times time is a change in momentum, right? And a change in momentum is m times change in velocity, right? So literally to answer this question, you're going to go 76 times 9.6, right? And that'll give you the answer, which rounds to about 730 Newton seconds, right? And then state an appropriate unit for your answer. Well, this one's kilograms. This one's meters per second, right? So kilogram meters per second is one of the units you could put, right? Remember to label your units. But also force times time, right? That's a force, okay? Force times time is in Newton seconds. So that would be another, these are the same thing. Newton seconds and kilogram meters per second are the same unit, okay? Now, spoiler alert here. I'm going to change this slightly, okay? I'm going to, I believe I'm going to tell you how much time it takes to stop the skier, and I'm going to ask you for the force. The force equals whatever, right? And to solve that, you're just going to use force times time is mass change in velocity, and you're going to solve for the force. And I'll tell you the time, okay? So that makes it a little bit more tricky, okay, but not really that much more tricky, okay? And then it says, explain with reference to a change in momentum why a flexible safety net is less likely to harm the skier than a rigid barrier. Right? Remember that they've got this doesn't change, right? But if you can make the if you can make the time bigger, that you slow them down, that is, you slow them down over a greater amount of time, okay, that will make the force less, okay? So with reference to a change in momentum, I think what you need to say is impulse is a change in momentum, right? Impulse is force times time. If time is bigger, then the force is smaller, okay? And that'll get you your 2 marks.